Hello everyone. Today I would like to discuss about operators in C language. Also, I would like to discuss about operator precedence and operator associativity. In fact, the concept of operators in C is important because if you are engineering students, uh, there will be at least one essay type question on operators in your examination paper. So you can give a higher priority to concept of operators in C language. In fact, the operator precedence and operator associativity will come into the picture when you would like to deal with mathematical expressions. For example, say I want to calculate the function x in terms of say a minus b plus c by d star say e. So if I want to evaluate these mathematical expressions, so we call them as mathematical expressions. Am I right? So which operation must be performed first? I could see there is subtraction, addition, division and multiplication. Among them, which operation must be performed first? And the operations to be carried out either from left to right or from right to left. So these are the two at most bothering issues for us when you would like to calculate the mathematical expressions. So if you want to uh, do the right operation, if you want to get the right value for the x, so one is expected to know operators as well as operator precedence, comma operator associativity in C language. So with that, let me proceed further and let us see how many operators are there in C. You could see there are see many operators are there. In fact, you can see on screen arithmetic operators, relational, conditional, increment and decrement, logical operators, bitwise, assignment operators, conditional operator. Sorry, it is conditional is repeated. Here we can say so conditional is repeated. So can remove it. Yeah, special operators. So among them, very few operators are to be known. They have to be known with little care. Otherwise, they probably you may do some mistakes while you write the C programs. So, of course, some of the operators are well known for us because we are using the operators in our daily mathematics. So let me define the operator first. If I write say C is equal to A plus B, so here plus is operator and a comma b are operands. Am I right? So based on this concept, you can define what operator is doing. I can see operator is altogether it is in symbol. Okay, you can see on screen operator is in symbol. It is in a symbol. What it is doing, it performs an operation. And operation on what? It performs operation on given operands, and gives the result. The result is given to C, right? And in fact, the operator working on how many operands again will form the concept called as whether it is unary operator or binary operator or ternary operator. In fact, say if I say x is equal to a plus plus, so here the plus plus we can say post increment operator. I say it is working on single operand. So if operator is working on a single operand, we call it as unary operator. So for example, if operator is working on two operands, here plus is working on A and B, then it is binary operator. So there are operators. I can say there is an operator called as a conditional operator, which can work on more than two operands. It could work on three operands, say x comma y comma z. So we will see when it comes in the today's session. So if the operator is working on single operand, we say unary operator. You can see unary operators are post increment, post decrement, pre increment and pre decrement. Arithmetic operators you can see on screen, all are binary operators. Arithmetic, relational, logical, bitwise, assignment, all are binary operators because they expect two operands to participate in the operation. So with that, let me proceed and discuss one after another, guys. So we will see initially arithmetic operators in C language. Yeah, um, The well-known arithmetic operators are plus, minus, multiplication, division, and modular division. So we call it as addition. This is subtraction, multiplication, division. This is modular division. So nothing is new about these arithmetic operators. So plus is used for addition. If I take say a is equal to, say let it be 2, and b is equal to say 4. So you can write c is equal to a plus b in programming. So you will get 6, and c is equal to a minus b. You will get minus 2. C is equal to a star b. You can write it. So you will get 8, and c is equal to a by b, or let it be let me write it as say b by a right now. So means it is 4 by 2, it is 2. And if I write c is equal to say what is that, say b by a again, that implies, so let me apply this modular operation percentile. So for percentile 2, it is 0. So in fact, the only among these arithmetic operators, the student has to focus more on this addition, division and modular division. So in fact, if I do c is equal to b by a, what is the result? Result is in fact, result is quotient. Result is quotient. And if I perform c is equal to b modular division a in C language, the result is, can you guess it? Result is remainder. The result is remainder. So these are the two important arithmetic operators student has to know. In fact, the modular division is used to get the remainder. Okay, so what are the other issues to be noted about these two is, so when you do c is equal to say 3 by 4, or say 6 by 2, or say 8 by 3, so int by int, integer by integer, always the result of division operation is integer. What it means, so 3 by 4 it becomes 0. Okay, 0 point something, it truncate that as 0, and this becomes 3, and this becomes 8 by 3. In fact, we get 2.6 something like, but this is truncated as simply as 2. Int by int is always integer only, but you can have see int by float. You will get the float value provided the resulting expression is or the variable that is receiving the value is float. Okay, so what are the other? Float by float, again it is float. And then see what is float by int, again float. Int by int is only always integer. Okay, that you have to remember. And what about this modular division operation? So yeah, so if I write c is equal to say 4 percentile 2, what do you expect? The percentile gives the remainder, so 4 percentile 2 remainder is 0. C is equal to say 8 percentile 3. What is the remainder here? So if you do the division operation, what would be the remainder? Remainder is 2. And C is equal to say 99 percentile 100. Even what is the remainder? Remainder is 99. If numerator is less than the denominator, if you apply the percentile operation, the result is always numerator. And remember, this modular division is applicable only on integers. You cannot apply this modular division on floating point values. And one more point I want you to remember, this modular division is applicable even on negative numbers. It could be minus 8 percentile 3. What is the result? Tell me. So result is, remainder is 2. It is prefixed with negative, because the result when one operand is negative, I can say that let it be like, say, 8 percentile. See, if it is minus 3, what is the result? Can you guess? In fact, it is positive. So result of this, you can note it down. Result of percentile is will have, or else will have sign of the numerator only. Sign of the numerator only. So it will not consider the sign of the denominator. It is applicable only on integer variables, and the result of this modular division operation uh, is always the sign of the numerator. This modular division operation, in fact, we apply to separate the digits from a given number. If I say n is equal to 123, if I want to separate this 3 from the number, so I can write x is equal to n percentile 10. So you can separate last digit of the number. So what is the remainder? 123 percentile 10. Now x becomes 3. In such a way, this modular division operator is normally used to separate the last digit of a given number. So that's about arithmetic operators, nothing else. Let me go with relational operators. So in fact, relational operators are used to check the relation between the two operands. Say if a is equal to 10 and b is equal to 15. So how they are related? I can say some c is equal to a less than b, c is equal to a greater than b, c is equal to a less than or equal to b, or c is equal to a greater than or equal to b, or let me check whether c is equal to b or c not equal to b. So these all are in fact are relational operators. So less than, greater than, less than or equal to, greater than or equal to, is equal to is normally represented with two equal to symbols, and not equal to. So these are the relational operators. The one most important point about the relational operators is they return a value after the operation. Okay, after the operation. What is that value? In fact, so if condition is true, if condition is true, condition is true, the return value, that is return value is 1. If else the return value is, that is 0. So remember, so relational operator, all relational operators returns a value. So based on this point, what is the result for this? In fact, so you can guess it. So what would be the c value here? C is equal to a less than b. A less than b, it is true. If it is true, it is 1. And c is equal to a greater than b, false, it is 0. A less than or equal to b, yes, it is true. A greater than or equal to b, it is false. Is c is equal to, sorry, c is equal to, let it be b, no, it is 0. Is c not equal to b? Yes, it is true. So c is equal to 1. So you can, wherever you use these relational operators, normally the relational operators are participating in conditions. So in the mathematical expressions where you are testing the conditions, where there we use the relational operators, they return value after evaluating an expression. So you can write now, if I write c printf, say percentile d comma c a greater than b, what would be the output? This output is in fact false. This is 0. So the one more point about this is, so in C language, so in C, any number other than 0, other than 0, either it is positive or negative number, is considered as true, and this value is 1. And if number is 0, if 0 is considered as false. Please remember, this is important point. Consider as false, and equivalent number is 0. Right, that's what the about the relational operators say. For example, if you want to write a simple C program to test whether a greater than b or not, we write normally a greater than b, printf a is big, else b is big. So what is happening? If a greater than b is true, the return value is 1, means if true we will execute the statement. That way we use the relational operators. And let me tell you, I would like to tell you about this conditional operator. It seems to be slide is overlapping the text. So let me explain what is conditional operator. So conditional operator is used to check the condition first, then it will assign the value based on the condition. So it is also called as ternary operator. In fact, this is a ternary operator, means it can work on more than two variables. You can see here, let me take a simple example. So it will test the condition. For example, say I want to assign greatest among the two numbers, a greater than b, and if a greater than b, so let me assign x as a. Otherwise, simply see, column is not here. Let me assign a. Otherwise, I will assign b. So here conditional operator is represented with question mark and colon. This is conditional operator. So if test expression is true, this test expression is true, we will give the expression 1 value to the variable, and if it is false, we will go with expression 2 value. So let I repeat again, if x is equal x a greater than b is true, simply assign a, or else how do you do that? So don't write here, or else you assign b. So to know the simply greatest among the two numbers, we use the conditional operator. So conditional operators normally used to optimize the if conditions in programming, and they can be nested also. See, if expression you can see here. So this logic greatest among the three numbers. So you can see. So if x greater than y is true, if x greater than y is true, you can initialize this as big. So x greater than y is true, we are going to see, let me take another color. So we are going to do this process. If x greater than y is true, if it is true, right? And if it is false, we are going to do this process. Means it could be an expression. Remember, it could be an expression. It could be an expression. So again, expression could be a conditional operator. It is also an expression. So in fact, for the knowing greatest among the three numbers, so if x greater than y is true, so this expression is assigned to the variable big. So again, it is an expression involving the conditional operator. I want to test it. So if x greater than z is true, means x greater than y is true and x greater than z is true, then I will assign x as big. But if it is false, means x greater than y is true, but x is less than z. What does it mean? Z is bigger. So we will assign this. In fact, this x greater than y itself is false. So I will come here. Means y greater than x. So when y greater than x, I would like to text again y greater than z. If y is greater than z, let it be y is big. Otherwise, z is big. Fine. So we will write a simple program so that you can understand even. So let me write, see, greatest among the two numbers can be written as include less than stdio dot h. Fine. So I want to use the conditional operator, right? So how can I do that? Yeah. So let me go with, let me declare two variables as integers, and I want to know uh, greatest among them, printf, yeah, enter AB, then scanf percentile D ampersand A comma ampersand B. Fine. So you can take the another variable, say it is big. Now big is equal to, how can I write, if A greater than B, if this is true, in fact true means relational operator returns, this is true, let the check, let condition be tested, and assign x is equal to A. If this is false, assign x is equal to B. So here question mark and column together forms the conditional operator. So now if A greater than B, A will be assigned to big or else B will be assigned. So after condition you can write to printf the biggest number is like percentile D comma B. You can go return 0. And give an example, we have written also greatest among the three numbers. If you want to write that, how can you do that? So first you check A greater than B, greatest among the three numbers, it could be written like this, big. You can scan three numbers, A greater than B is true, you do one thing here, else you do other thing. And what you need to do here is, if A greater than B is true, then I have to check whether A greater than C is true or not. If A greater than C is also true, assign A as big or else B as big. So this would be the expression 1. So if it is E1, expression 1. And if A greater than B is false, so I said, so we will come here. So the expression 2, let it be, how you can write the expression 2. So this could be, so A means A greater than B is false, means A less than C, A less than B. So means B greater than A. Let me check whether B greater than C or not. If B greater than C is true, means B is greater than A and B is greater than C, assign B as big. Or else, if B is greater than A but B is less than C, assign C as big. So this would be the logic, semicolon. This should be the logic to find the greatest among the three numbers using the conditional operator. So with that, let me move on to increment and decrement operators. In fact, this increment and decrement operators are used to add or subtract, uh, 1 to the operand. I said these are unary, mostly they are unary operators, they work on single operand. So let us take, initially there are two categories, pre-increment and pre-decrement, post-increment and post-decrement. So let me say I have the value A is equal to 5. So let it be x is equal to, I can write, how do you represent this pre-increment is, simply it could be like plus plus A. And the other hand, I have B is equal to 10 and my Y is equal to, say I can say pre-decrement as minus minus A. So here plus plus represents, before the operand represents the pre-increment, and minus minus before the operand represents the pre-decrement. So plus plus A means it will add 1. So this operation in fact can be understood like this. So initially what happens, this operation could be rewritten like this: A is equal to A plus 1 happens first, and then x becomes A. Here also same. So A is equal to A minus 1 happens first, then Y becomes A. So what would be the values of A and Y after this? So A becomes 9, Y also becomes 9. So that's what the predicament. What happens here? So A becomes 6 and 6 is assigned for X and X becomes also 6. But it is not the case with post increment operators. That's what the student has to remember. So maybe in the competitive exams you may be given one expression which involves these operators. Then you must be careful little. Okay. So if this is the case, let it be say m is equal to, I say 20 and n is equal to let me say 30, and say y is equal to post increment means it could be written as m plus plus. Post decrement means see z is equal to say n minus minus. So how do you interpret this? Is also you can interpret this as two operations. So what happens now? Y is equal to, because after equal to, what is there? Variable is there. Y is equal to m happens first, then m becomes m plus 1. So means what would be the value of y? Y is 20, and here m becomes 21. And same here also, what happens initially? Z is equal to n is initialized, then n becomes n minus 1. Fine. So because of that, so Z will be initialized with 30 and n becomes 29. So if you look at this after operation, here two variables, they have different values. Here also they have different values because of the nature of the operation. But here the two operands have, in case of pre-increment or pre-decrement, two operands have the same values. Same values. In fact, what happens in the general expressions, it could be written as x is equal to, they say that a plus 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 b. So they will give the expression like this: if a is equal to 5, b is equal to 10, what is the value of this expression? So you can see x is equal to, what happens, this is a post increment. So initially, so a is substituted here, value of a, so that is 5, and this is post pre-increment. B is incremented first, then value is replaced. So B becomes 11 and 11 is replaced. That's why X becomes 6. So you need to do some exercise to understand the concept of this increment and decrement operators. Fine. So if you want, you can write a simple program also to understand the concept of increment and decrement operators. So let me move on to the logical operators. In fact, in C language we have three logical operators. We call them as logical and we say logical and, logical or logical not. So what are these? So these are used to test the multiple conditions. In fact, when you apply, these are binary operators. Say let me take the operator A, operand A and operand B, and let me assign the values. So true and true, true, say false, and false and true, false and false. If operand say A is true, what happens if I apply this logical operation A and B? True and true, truth table, we know it in simple mathematics, it becomes true, and this is false. This is false because if one is false, and operation is false. If it is A or B pipe symbols, two parallel pipe symbols, that constitutes the logical operation. So what happens if true, one true is there, result is true, 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 uh, false and true, it is true. Am I right? And this is only false. So these logical operators are used to find the result of the two or more expressions which are involved with the help of the logical operators. Logical not, simply if you apply this logical not before true, the result will be false. So as I said earlier, true is represented, any positive value in C language is represented as true, and negative value, only 0 is represented as 0. So this can be used to see, for example, if I want to test a condition, if A greater than B and A greater than C, so what happens? I simply print A is big. You don't know about the printf right now. Okay, later we will see. Means what is happening here is, so let me add this. So a greater than b is evaluated to be true, means it is 1, and a greater than c, if both this is also evaluated to be true, in fact assume this becomes 1. True and true becomes true, the condition becomes true, the statement gets executed and it will print a is big. So in the similar way, the or operation and not both are used. So in fact, see, if a is equal to 5, means it is true. Any positive value, it is true. If a is equal to 0, means it is false. Even if I write a is equal to minus 5, I want you to understand it is also true. Okay, so if b is equal to, if apply negation of a, so then what is the b value? If a is see, if a is minus 5, it is true. If you apply the not before the true, then b becomes false. Am I right? That's it. So that is the way how these logical operators will work. So assignment operators, nothing more about the assignment operators. Simply we say assignment operator is used to assign the values to the variables. The short form of the assignment operator, sometimes it could be written as a plus is equal to 5. It implies a is equal to a plus 5. This can be applicable with all the other operators. For example, see, I can write, say, a slash is equal to, say, b, that implies a is equal to a by b. So assignment operator is basically used to assign the expression or the result of an expression to a variable. And one more important operators in C language, sometimes this question may be asked as essay type question, is bitwise operators. Basically these bitwise operators, almost they works like a logical operators, but the difference is that they will operate on bits. For example, if I say C is equal to a and b, so here and is a bitwise operator, this pipe symbol is a bitwise, and this is a exclusive or operator. So we say this is a bitwise and, bitwise and, bitwise or, and this is exclusive or. You can see. So in case of logical and, we have two ampersands. Logical are two vertical lines are there, but for bitwise operators only one ampersand and one vertical line is there. So try to understand, the bitwise operators will work on bits of the operands, will work on bits of operands. So means the operands are converted into binary form first, later we will apply the bitwise operators. For example, let me initiate, say a is equal to 4 and b is equal to, say, 5. Fine. So if I write c is equal to a and b, so I have to convert the a first in the binary form. I wish you know how to represent the decimal number into binary form, divide it with 2, and I will get the equivalent binary value of the 4. I can write it as 100, and equivalent binary value of this b is 101. So what we will do is, we are going to apply this. So how this happens, 100 and 101, AND operation is applied. Now it becomes a logical AND. So if both are true, both are ones, then only it is 1, otherwise it is 0. So what happens, 0 1 it is 0, 0 0 it is 0, then 1 1 it is 1. So the result is 100. What does it mean? Then see, if you write printf, say percentile d comma c, what is the resultant value? See, again it will be converted in the decimal form. You will get the decimal value 4. So you can see that the both the operands are true, then only it is true. And for OR operation, if both are 0, then only it is 0. But exclusive OR is different. If I apply A exclusive OR B, what happens? So if both the operands are same, then it is 0, and both the operands are different, it is 1. So I can see 100 and 101. Let me apply this. So if both are different, it is 1. If both are same, it is 0. It is 1 1, it is 0. So if I write printf, percentile d comma c. What is the value? Can you guess it? It is decimal 1, so 1 will be printed. Apart from this, we have also two more operators, three more operators. In fact, we call it as left shift, right shift, and what is that? One's complement, we say it is a tilde symbol, one's complement. So you are also supposed to know these two also. For example, if I say c is equal to, we say less than, that forms the left shift operator, it is 2. So, and at the same time you can write c is equal to b right shift of 2. So what happens? What would be the value of c? So I said the bitwise operator operates on bits. So first thing is, let me give the a value is, say, let it be 4, and b value let it be, say, 16. Now we have to convert this now into binary form. So let me write the first expression. C is equal to a left shift 2 becomes 100 left shift of 2. So in fact, the binary representation of A, as I said earlier in the previous lectures when we are talking about this C data types. So how much? Because if it is A is a integer, 4 bytes of memory means 4 bytes means 32 bits. The first bit is used for the sign 0 because A is being positive, and last three digits actually they are 1 0 0. Am I right? So what about the remaining? All are zeros. So all are zeros. All are zeros. So what this expression is demanding? So you shift the bits of A towards the left by 2 positions. Means this 1 has to be moved 2 position towards the left. This 0 has to be moved 2 position towards the left, and this 0 has to be moved 2 position towards the left. Then what happens? The resultant would be uh, so resultant would be 0 because it is being positive. All are zeros. Say every bit is moved 2 positions, then 1 comes here, 0 comes here, and 0 comes here, because 2 vacant positions are created, because every bit is moved towards left by 2 positions. So the vacant positions will be filled with 0. So then this would be the becomes the uh, resultant value. So what would be the value of this? In fact, how many bits are there? So it becomes c is equal to, if I write printf percentile d comma c, what is the resultant value of this binary number? In fact, it is 2 power 4, that is 16. So you will get value 16 here. And if it is right shift, that happens in a different way. For example, in the right shift operation, what we are doing, yes, so what we are doing is c is equal to, I said c is equal to b right shift up 2. And what is the value of c? B is 16. Now it is actually 100 0, but in fact we have to take the memory representation of b, not the actual representation. So right shift 2 positions. Imagine that being it is positive, most significant bit is 0, and so on. So how many bits are there? 1 0 0 0 0. So move this move these bits towards right by 2 position. If I shift these bits towards right, there is no empty space. In fact, okay. So there is no empty space. Empty space is towards the left. All these are filled with zeros. That's okay. By adding zeros towards the left, that won't change the magnitude of the number. That is fine. But when I want to shift these values towards right, I don't have any space, because you would like to move the digits to position towards the right. What happens? So this comes, this bit overflows and this bit overflows, and these two bits, these three bits moves to position toward the right. So what would be the resultant? It could be like being positive 0 0, so on. So this 1 0 0 comes here, and 2 overflows, 2 bits overflows, 2 zeros have gone. So then this would be the resultant value in fact. So what is the resultant value? If I write printf percentile d comma c, what would be the value? This is 4. So in fact, you can also straight away you can write, if a is c power of 2, left shift operation increments the value by a multiplied with 2 power n bits. N is number of bits to move towards the left, provided a could be expressed in terms of 2 power something. And then you can also write, if right shift can be written as, this could be the value of uh, b by you can write 2 power n, provided b is expressed as 2 power something and n is number of bits moved towards the right. So this is about the bitwise operators. Probably in examinations you may be asked. So this is the basic funda. And apart from that, we have special operators. So we have seen size of operator is being used to find the size of the inbuilt data types. Ampersand represents the address of a variable. So we are scanning and placing the values of the variables which are scanned from the keyboard in addresses of the variables in the memory. And star in fact is used to represent the pointers which we come across very soon. Int star a is a integer pointer. Of course, we have seen conditional operator. It could be represented as a special operator also. Apart from that, dot and arrow are also special operators. We use them with structures. If you write struct, say a student, okay, and student will have roll number into roll number. So we don't know about the structures, so later on we will discuss. If you create any variable of structure, say struct say student, yes, to access the variables of a structure we say s dot roll number is equal to 1. Or you can also define a pointer to this structure, let it be struct student s1. In such case, if you want to assign access the values, we use this member selection operator arrow s1 arrow of roll number is equal to say 100. So this way we use these selection operators. So, okay. Yeah, now the point is I want to talk about the operator precedence and operator associativity. Look at here. So because now we come to know what are the various operators. If I have written x is equal to 10 plus 20 star 30. Now the question is, it can be done in two ways. Case 1, so my x value would be 900, and case 2, my x value would be 6, it could be 610. So 900 means here plus is performed first. So if plus is performed first, we will get 900, right? 10 plus 20 becomes 30, 30 star 30, 900. And if star is performed first, we will get 610, because 20 star 30 it is 600, 600 plus 10, 610. So which operation must be done first? So that will be decided by the concept of operator precedence. The operator precedence will tell, so which operation must be evaluated first when mathematical expression having more than one operator. So that is the definition. So in fact, so here you can see we have performed the star first. So that is the reason why 60 is added with 10. Sorry, 60 is added. I think it's wrong. They have done it wrong. 600 is added with 10. So we have got the 610. So means star is performed first. We will tell that star has to be performed first. In mathematics, I think the students will use that BADMAS rule. So same rule can be applicable here also. So operator precedence will tell you which operation must be done first. In fact, okay, from that we will get it. We will see the operator precedence short. So star is given higher priority than the plus. So star is performed first here. Fine. But if see, you can see operator associativity is defined as, now I have the expression that has division and star. If you look at, so means the expression is having, expression consists of operators of equal precedence, operators of equal precedence. In fact, if you visit the operator precedence table, of course, among the plus and star, the precedence table says that star is given higher priority, we do star. But among the star and division, all they are equal. The priority is equal, which we will see in the next slide. A precedence chart is there. Fine. Then the problem is, so either division is performed first or star is performed first. You can see here on screen. So because division and star both have the equal priority. So in such case, the operator associativity will tell you that. So for example, I have division, star and modular division. They have equal priority. If they appears in the expression, so which operation must be done? The operator associativity will tell you that. So you evaluate the expression either from left to right or right to left. So for example, for this expression, so these arithmetic operators have the associativity from left to right. What does it means? You start from left. Whatever the operator comes first, whatever the operators comes first, you do that operation. That's what the then go with the next operation. So left to right associativity will tell you that. So when equal priority operators appears in a mathematical expression, you start evaluating the operators from left to right. So now the sensitive issue is the student has to know operator precedence chart is there, which operator is given which priority, what is the highest priority operator, least priority operator, precedence chart. And also you must know associativity of the operators, because many operators have equal priority, which we have already discussed. So the slide is given here, you can see. Yeah, so least priority operator I want to talk about, it is comma actually. So least priority is operator, if I say x is equal to a comma b comma c comma d, sorry, c comma d, so the least priority operator is comma in the sense. So first this is done, then we evaluate the comma. So x is equal to a happens, so then we go with comma, so nothing happens. So if I say, so x is assigned with a, the rest is ignored, so means equal to operator is also having higher precedence than the comma. Comma is the least precedence operator, remember, least precedence operator. Then what are the higher priority operators? So these are the, so post peaks, this according to the BATMAS rule, we have parentheses are given higher priority, then brackets, member selection, post increment. If I write x is equal to say a star b plus c, in fact star is performed first, but if I open the brackets here, so here plus is performed first because the first priority given to parenthesis, right? And also post me, they have all are equal priority in fact. But if the expression involves say like see x say plus let me write x plus plus or a plus plus, then what happens, parenthesis and a plus plus has equal priority, but the associativity tell left to right. So I start from left to evaluate this expression from the left. So student has to remember the precedence of the operator, precedence number of the operator, and also the associativity. And you can see multiplication, division and star, this have higher priority than over the addition and subtraction. So that's why we do these operations prior to subtraction and addition. So yeah, and you see the one point I want to tell you, if I write x is equal to say a plus 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 um, plus plus b, so which one will be performed first? Because post increment is given higher priority, a plus plus will be performed first. These are the pre increment and pre decrement. So then pre increment will be given priority. Then what about this left to and left to right and right to left? In fact, the pre increment is right to left. What does it mean? So y is equal to, if I write, so plus plus b plus minus minus b plus 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 b. If I write this, so what happens, they are this all are pre increment operators in the expression, and pre-increment and pre-decrement have the same priority. In such case, what happens? So the associativity you have to refer. The associativity is right to left. So first we will do plus plus b. So right to left comes from right to left. This is 1, and then you have to perform this. This is 2, and you have to perform this, and this is 3. So I request the students to practice simple mathematical expressions and write a program on it and see the output what you are getting. If I write printf, say percentile d and y, so what would be the y value? So you assign some b is equal to 10 and see what you are getting. According to the norms, you are getting the right value or not. So the more you practice, the more you could learn about these operators, operator precedence and operator associativity. That's it from my side, guys. In the next tutorial I am going to discuss about the control statements. Thank you.